All right. I would like to welcome all of you to the fall semester water lecture series. Before I introduce our first speaker for the semester, I would like to tell you a little bit about the water lecture series. This is a series, and we are very, very happy to have it in the department that we used to bring accomplished scholars from around the world to the Department of Civil, Environmental, and Geoengineering. And this series is made possible by a generous renewing gift by Alice Warren Garton in 1961, and we would like to thank her for that. It is my pleasure now to introduce the first speaker for the semester. He's someone that I've known for many, many years. We were colleagues at Penn State many years ago. Right. Dr. Jian-Shiuh Chen. He's a professor at National Chen Kung University in Taiwan. He has been very active in teaching research and practice for over 2 decades in pavement engineering and materials. Before becoming a professor at the university in Taiwan, he actually was an assistant professor at Asian Institute of Technology in Thailand, and also was a research fellow at Federal Highway Administration, where he did the research in accelerated pavement testing with their accelerated loading facility. Right. He currently serves on the executive committee of the Transportation Engineering Project Evaluation of the Ministry of Transportation and Communications, and also is serving or served on several national and international advisory committees. His first degree is from the university in Taiwan. Then he did a master's at Georgia Tech. He applied to a number of schools for his Ph.D., including the geomechanics group at the University of Minnesota, but he ended up going to Penn State, where I met him, and we had a very good time as graduate students. Right. With this, please welcome Professor Jian-Shiuh, who will tell us about recycling for performance from academia to industry. Jian-Shiuh?
I'll use my microphone, all right. It's an honor and a privilege for me to share my experience with all of you here, and thank you for coming to today's presentation. Actually, the topic I would like to present today is my personal journey from academia to get contact with the paving industry in the project. Let me use this here. Since some of you may not be familiar with Taiwan, so I would like to show you, give you a little flavor of Taiwan. Taiwan is a small island here, situated southeast of the Asia, and it's about 180 kilometers of coastline of the mainland China. And I give you some statistics about Taiwan as well. The total area of Taiwan is about 36,000 square kilometers, which is smaller than Switzerland, but larger than Belgium. Is about the size of Netherlands. That's how big Taiwan is. Taiwan has a population of about 23 million people. Well, it's one of the most densely populated area in the world. And the shape of Taiwan is like a sweet potato. So people in Taiwan like to call them children of sweet potato. That's Taiwan. And Taiwan is characterized by the contrast between the Rocky Mountain in the east and the flat plain area in the west, and where the most highways are built. So this number here indicating the highways. And we have 3 big cities, Taipei, Tainan, and Taichung, and Tainan. Tainan is the city where I come from. This is the first map of Taiwan drawn by Dutch in 1658. That was a long time back. Taiwan was called Formosa back then, meaning beautiful island. And because its magnificent landscape and cultural diversity, Taiwan attracts many visitors around the world. And then Professor Marastino's daughter went there last year, and Professor Gananovich went there 2 or 3 years ago. Well, last year we received about 10 million international visitors from Taiwan last year. It's a Thailand city where I come from at that time. This is the map of the Thailand city in 1681. Thailand city was the capital of Taiwan in Qing dynasty. And a military leader, Chen Kung, recovered Taiwan from the hands of the Dutch and began his reign in Taiwan from Tainan. And my university, National Chen Kung University, is named after his given name, Cheng Kung, meaning successful. So that's how now it's located in the western part of the eastern part of the Tainan city. National Chen Kung University, NCKU, was originally established during the Japanese colonial day. It was called Tainan Technical Knowledge at that time, 1931, that's when it was established. NCKU right now serves 21,000 students, 39 colleges, 39 departments, and 49 graduate institutes. And NCKU is one of the most prestigious universities in Taiwan, with a high reputation in science, engineering, and medicine. And NCKU, U.S. News and World Report ranked NCKU the 22nd best global university for engineering and computer science in 2014. So that's my brief introduction of my university in Taiwan. And now come to the overview of my presentation. First, I would like to mention why we use reclaimed asphalt pavements, wraps. Then I would like to point out the challenges using high wrap content. Using a test roll as an example, I would like to elaborate key point to wrap mix quality and wrap quality. And after presenting pavement performance of asphalt pavement with a high wrap content, I would like to conclude my presentation with the important point you might take away from today's talk. And I will appreciate your input and comment during the Q&A section. Asphalt trivial. Well, how many metric tons of hot mix asphalt, HMA, mixtures are placed per year in the U.S.? Any guess? A billion. That's the total. Yeah, that's the total that the metric ton put in the U.S. right now. That's right now. So that's a good guess. But according to a survey conducted by the NAPA in 2013, NAPA stands for National Asphalt Pavement Association in the U.S. And the amount of HMA mixtures placed per year varies from year to year, depends on road condition and budget constraint. So average-wise, there are about 400 million metric tons of HMA placed per year in the U.S. Then the next questions. How many metric tons of HMA are recycled per year?
200 million.
Oh, that's a good guess. That's a good guess. Excellent. According to that survey, it's over 70 million metric tons of HMA recycled per year. So asphalt pavement is the American most recycled products. The next two most recycled products are steel and papers, with 60 million and 30 million metric tons per year, respectively. Okay. Reclaimed asphalt pavement wrap is generated when asphalt pavement is milled using the milling machine here inside. They have a cutter to cut the asphalt pavement, or full depth remove using bulldozers for reconstruction and resurfacing purpose. why we use wraps then? Well, recycling asphalt pavement first became popular in the US in 1970s during the oil embargo because the price of crude oil skyrocketed at that time. I'm sorry, go back. Wrap is variable alternative to virgin materials because it contains variable asphalt cement, usually in the range of 3% to 6% by weight. From contractors' viewpoint, high wrap contents results in lower mixed cost. The use of a wrap also conserves energies and lowers the transportation costs required to obtain quality aggregate. Also, using wrap preserve natural resources such as virgin aggregate and virgin binders. So optimally, recycling asphalt will create a cycle that sustains the environment. As highway agencies around the world are pressured to be greener and to further the use of environmentally sustainable product, and we look at the ways to increase the use of wrap in HMA mixtures. An upper limit on the amount of wrap can be used usually is specified in the specifications. On average, the US uses a little bit more than 20% of wrap in the wearing cost, which is on the surface. And Japan successfully used, on average, 47%. And Taiwan, the maximum wrap we can use in Taiwan is 40%. Actually, the technique I'm going to talk about today is based upon we have it in the Asian area. So it's a little bit different from what we practice here in the US. And high wrap content is defined as more than 25% of wrap in an asphalt mix by weight of the total mix. And the question now we are posing actually around the world is, how can we put in more wrap and ensure that these higher quantity do not adversely affect the long-term durability and fuel performance of our mixtures? That's really a big issue. Besides academic development, which we are doing right now, I feel that the biggest impact can be made is in the processing and production in an asphalt plant. That's why I will focus on today. Combining high wrap with the virgin aggregate introduces unique challenges when the wrap contains aged asphalt and may act like a black rock. If the wrap material is black rock, the aged asphalt has no interaction with the virgin aggregate at all. Now, how much could the aged asphalt in wrap be mobilized to blend so that the aged asphalt can be used and therefore reducing the amount of asphalt cement needed? In other perspective is how can we improve the interaction between the old binder and new binder in the asphalt plant? And these are the challenges we face in academia as well in the paving industry. Using high wrap contents in an asphalt mix usually require that a recycle agent be used. The recycling agent can be divided into softening agent and rejuvenating agent. The softening agent is a softer asphalt cement, such as PG, I'm sorry, I have to use the asphalt term here, such as PG 58 minus 28 instead of PG 64 minus the 22. That's what we use here in the US, using PG grading systems for asphalt. But in Taiwan, we still use traditional viscosity grading systems. So we use AC10 as a softening agent instead of AC20. Right. The rejuvenating agent here is a chemical product aimed to restore chemical and physical property of asphalt cement, of aged binder actually. And this table here provides the specifications of rejuvenating agents according to Asphalt classification. And in this study I'm going to present here, we use the IA75 with the viscosity value ranging from 5,000 centistroke to 10,000 centistroke at 6 degrees Celsius. So that's the rejuvenating agent. Guideline for the use of the asphalt recycling agent can be found in the Asphalt specifications. When the Wrap content is less than 15%, the contribution of the Wrap is too small to make any difference, so there's no change in binder selections. When the Wrap content is between the 15 and 25%, the new binder should be a softening agent, as I mentioned previously, and then that should be dropped one grade lower than the normal one. So in this case, we use AC10, which is pretty much equivalent to PG58 minus 22 here in the US. It's about the same grade. And when the red binder is more than 25%, a blend chart should be used to select the recycling agent. Usually it's a rejuvenator. And all these selections here are based on an assumption that the significant blending exists between the old binder and the new binder. That's the assumption they make in this table here. However, whether the blending occur in the asphalt plant remain unknown. So we don't know what happened there actually in the asphalt plant. And therefore, the project I'm working on is a test road was completed in 2014 to monitor how asphalt pavement with a high Wrap content will perform under real traffic and environmental condition. And 3 test sessions include in the test road, and we have 0% Wrap, 40% Wrap, and 10% Wrap. And the 0% Wrap test session is used as a control test session where all virgin materials are used. For each test, for each Wrap content of 300 meters, the test section was constructed. And this route here has an average daily traffic volume of approximately 12,000 vehicles with a 12% truck. And each section consists of 10 centimeter dense graded asphalt over 30 centimeters crushed aggregate base. That's how we constructed there. Using this test road as an example, I would like to show you how we control the Wrap quality and Wrap mix quality. It's essential to crush and screen the Wrap materials under a roof to keep the Wrap material dry. And we take great care in minimize the Wrap, the water usage during the crushing operation. To maximize the Wrap usage and still meet the gradation, volumetric property, mechanical properties, it's necessary to fractionate Wrap into at least 2 sizes. So in this study, the Wrap material is split into at least 2 sizes. The coarse Wrap material, which stay on sieve, 12.5 millimeters. The fine Wrap material is which is passing 12.5, C 12.5 millimeters. The recycling of previously recycled pavement is called asphalt re-recycling. Asphalt re-recycling now has become widespread, yeah. And, but currently there's little scientific knowledge about how and how many times asphalt pavement can be recycled without, while maintaining its durability. That's the issue. So the asphalt recycling specification in Taiwan include the following standards for wrap material. And the wrap must have a minimum asphalt content of 3%, and the penetration value of the extracted binder, which is aged binder, should be higher than 15. All these standards actually are easy to follow and to monitor in an asphalt plant. So the experimental design in our studies include only one virgin aggregate, which is limestone, and one wrap source, as I mentioned, is the fine wrap material. Well, the fine wrap material usually had greater asphalt content than the coarse one. That's why we use it, because we want to extract more the variable content. And both binder content and the penetration value met the standards I mentioned previously. So that's why we use this type of wrap here in our study. And 3 wrap contents were used, 0%, 10%, and 40%. And one rejuvenating agent, which was I-75, was used for the 40% wrap text sections. 2 virgin binders were used. AC10 was used as a control for 0% wrap text sections. And the AC10 was used as softening agent for 10% wrap text sections. A detailed explanation of wrap mix design is beyond the scope of today's presentation, but the basic principle is that asphalt pavement with wrap and without wrap should meet the same requirements. So this figure here shows the aggregate gradation for all the mixtures we use on the test road, and the nominal maximum aggregate size used was 19 millimeters. And the asphalt content was determined to be 4.9% for all the mixtures we use. So we maintain the same asphalt content used. And a blending chart was used to determine the required grade of the recycling agent. And the target viscosity we used was 2,000 poises at 60 degrees Celsius. So that's a control point for all the blended asphalt used in the mixtures. So that's very important. We use 2,000 here for the control point. And the binder replacement ratio is defined as the percentage of wrap asphalt content divided by the total asphalt content in an asphalt mix. And the use of a rejuvenating agent here would increase the binder replacement ratio to be like 36.7% for 40% 40% wrap sections. So what I'm saying here is that the use of a rejuvenator will make the recycled asphalt concrete greener, which is more wrap that you can put into if you use rejuvenator. There are 4 major characteristics of wrap mix production in Taiwan that might be different from the practice here used in the US. The moisture contents in wrap will be kept minimized using a roof cover. A batch plant is used for the wrap production, mix production in Taiwan instead of a continuous mix plant here used in the US. A separate drum is used to dry and heat the red materials. And the rejuvenators will be mixed with, directly with the heated red in the surge bin. So these are 4 major differences. I would like to illustrate all these characteristics using the following slides. Okay. It's essential to cover the wrap stockpile, is a wrap stockpile here, under the roof of open-sided building, as I shown here. Moisture in the wrap stockpile will be more difficult and more expensive to remove as compared to virgin aggregate. In general, it takes a 10 liter of film per metric ton of aggregate to remove 5% moisture content and heat it, the asphalt mixture to mixing temperature around 160 degrees Celsius. So moisture in wrap will take more film for drying the same amount of water. And using a cover here would keep the moisture content of wrap stockpile below 2%. So that's a significant reduction there. And in addition to the moisture content, it's important to increase sampling and testing frequency to make sure that the quality of wrap is uniform in terms of binder content, asphalt property, aggregate gradation, and aggregate properties. The major difference in wrap mix production between Taiwan and US is the use of a batch plant. The batch plant is flexible in a way that we could change from one type of mix to another one without difficulty. And so the batch plant is very popular in Asian area and in some European countries as well. This drawing here showing the parallel heating systems in a batch plant. The parallel heating system use a separate dryer to dry and heat the aggregate, the red material. The red material will come underneath here, and the red material comes in indirect contact with the frame. And then they will preventing the creation of overcooked wrap and emission problem, and also black smoke. So that's important here to use different dryer. And then the wrap material will drop into the surge bin here, where a rejuvenator will be mixed with the wrap material, giving time to activate and conditioning the wrap material in the surge bin. And after that, the wrap material will put into pulp mill to mix with the virgin aggregate coming from this direction and virgin asphalt coming from this direction. That's, using a separated dryer, it allows asphalt mixtures with a high wrap content. That's the basic concept is here, because we have a separate dryer, so we can use more wrap in the asphalt mixtures. And this photo shows the wrap dryer for the production of asphalt mixture with the high wrap contents. The wrap material will come in underneath here, and this wrap material is indirectly heated in the dryer because we have a hot air stream coming back here from the gas chamber. And then the wrap material will be transported and to this surge bin here, where the rejuvenator will be mixed with the wrap material And then, so for about 2 hours in our study here. And then, so the merit of conditioning red material is that it allows the rejuvenator to diffuse into the aged asphalt in the asphalt plant. And this photo shows the heated red materials after separate dryer, the wrap dryer. So this heated wrap here had a dry appearance, acts like a black rock, just like black rock actually is. We don't have an interaction yet, we can see here. And this photo shows the rejuvenated wrap materials after surgery, after conditioning for 2 hours. So the rejuvenated wrap was well coated and uniform, as we can see here, has appearance of fresh HMA mixtures. And the rejuvenators appear to penetrate into the wrap binders after condition in the surge bin, as I show in this photo. So the diffusion process of a rejuvenator in a surge bin can be described in 3 stages, given that we have no given virgin aggregate is used here. So in the beginning, the rejuvenating or the recycling agent forms a low viscosity layer, like here, coating all the red material that's still coated by the aged asphalt here. So at this stage, asphalt mixtures with the high red content actually might be subject to rotting, because the recycling agent acts like a lubricant. So that's what will happen. And then gradually the recycling agent begins to penetrate into the aged asphalt, forming increase in the viscosity value of outer layer here. At the same time, it also softens all binder inner layer. And asphalt mixture with the high red content will start to develop strength and then to carry traffic loading at this time. And eventually, the rejuvenator, the blending will approach equilibrium here. So asphalt mixture with the high red content will be able to develop sufficient strength to provide resistance to traffic loading, thermal cracking, or fatigue cracking. So this is the final stage we want to have with the high red contents. And all this can be done in parallel heating systems. So in my presentation, actually, the key point is careful selection of the recycling agent and the use of parallel heating systems will shorten the sort of diffusion time and develop the strength more rapidly. That's what we try to use here, that for the asphalt mixture with the high red content. Surveys of pavement performance, including rotting, friction resistance, or ride quality, or cracking, were conducted at scheduled intervals. And I've been fortunate to have excellent graduate students working with me throughout my academic career, actually. So I would like to acknowledge their efforts put into all this work here. So they're working really hard. It's summer in Taiwan. The temperature can run as high as 120 Fahrenheit, and humidity is approaching 100%. So that's a difficult job they are doing here. No, I'm not kidding, really. That's so I'm out with them. It's difficult work. But I will not mention all the pavement performance characteristics. I only use 2 performance that I will present in this talk here. pavement skip resistance was measured by the British pendulum tester and expressed by the British pendulum number, BPN. And each bar here represented the average value of the three tests with the tick indicating the one standard deviation. So this figure here shows that the initials, sort of initial right after construction, the initial BPN value was a little bit low in the beginning, but the pavement skip resistance was improved after test section opened to traffic because the asphalt film coating the aggregate will disappear after it's open to traffic. So that's what happened here. And a BPN value higher than 45 is considered to be safe and sufficient for roadway. And so according to test result here, all test sections provide a good wet weather friction. And permanent deformation. Well, the rotting situation was improved right after the construction. And the severity level is considered to be low because all the rot depth is lower than 12.5 millimeters. That's what we see here. So all test sections possess good resistance to permanent deformation or plastic deformation or rotting here. And these photos are for the 40% wrap test sections and before construction and after construction, which I took in June this year. And all test sections here are showing to have satisfactory performance after 24 months in service, and no cracking or observed or raveling is observed on the test sections. I would like to conclude my presentation here regarding to wrap quality. I think it's important to minimize water usage during the crushing operation for the wrap materials. Fractionating wrap into at least 2 sizes will improve the wrap quality. And then it's important to establish standard for asphalt recycling materials. And covering a wrap stockpile on the roof will minimize the moisture content. Increasing sampling and testing frequency will make sure the quality of wrap material is uniform. In terms of the wrap mix qualities, heating wrap in a separate parallel layer dryer and mixing and conditioning wrap with a rejuvenator in a surge bin would address the blending issue, which is critical issue for the asphalt mixture with the high wrap content. So we try to address the issue using these 2 concepts in our study. According to test results we have on the field, asphalt pavement with high wrap content perform equivalent to the test section with the virgin HMA mixtures. So, these are Chinese characters basically saying it's the end of my presentation. If any questions, please, I'll be happy to answer them for you.
Okay, so we have time for questions, and you have to actually use the microphone since you are closer.
Yeah.
Great presentation, Professor. My name is An from Mindat Research.
Yes.
So on the slide, you show the 3 phases of diffusion between rejuvenator and aged binder. How are you able to check the complete diffusion?
That's a very good question. We can.
Okay.
That's why we try to use the separate dryer. So we can. Nobody can say at this
I was
moment.
wondering about that.
No.
Second question is slide 37.
37, wow, you are recording. That's great. 37, all right, here.
What do you think that caused a higher drop in BPM number on those are two sections, rep 10% and 40% section? What's your opinion about it?
That's very good eyes you have there. I try to hide it from you, but you point out. That's a big issue right now in the world that they are concerned about the low friction characteristic of using wrap. And I don't know this issue yet though, and because it's all complicated. Here I have a low, after, let me see, after 18 months, I have a lower friction value here. You're right, there will be a concern if this BPM value drop below the 47. If that happens, then there will be a major concern. At this moment, we don't have that issue yet, but that's a very good observation you have.
Thank you.
Perhaps on a per volume or per ton, what is the energy cost for the wrap versus the energy cost for virgin aggregate in terms of preparation? Is it comparable, or does wrap require more energy, assuming that it's covered and we followed your recommendations?
That's another good question. You are talking about the carbon sort of this life cycle assessment issue here. That's another study I'm trying to look at right now. I don't have the data, but I'm going to collect all this data with the consultant company in Taiwan. But my perspective understanding would be that the wrap material will cost more in terms of this sort of carbon assumption. I don't have value yet, but I would be happy to give you one if I have one big in Taiwan. So give me my name card, your name card, and I will send it to you.
Very good, thank you.
Thank you. Very good question.
Okay. I have a question. In concrete, when we recycle concrete, it's very important first to investigate why the pavement failed in the first place. Here we talk about wrap, you're just using generic term. So is it important what was the cause of failure of the old pavement before you start using recycled asphalt in the new pavement? For example, it failed in rotting, and failed in cracking, and failed in something else.
Oh, you're talking about the reason why the payment failed?
Yeah, previous payment failed.
Wow, there's very issue. Primarily in Taiwan, the value, well, I have to keep this as a secret here because I think that's because of the construction issue. To be honest with you, I mean, I think if the payment is properly monitored and the material meet the specification, I don't think there's too much problem there. We can last probably as long as 10 years or more. But then the paving industry will lose money because we make the pavement endurable. So there's a very complicated issue here that you are talking about. But you're right, though. Let me go back to there's other issues like weathering or trafficking in a different that area we can look into it. But I would say heavy traffic loading is also another big issue for the asphalt pavement because these manufacturers tend to overload their truck. They can save money. And when they do that, the pavement was subject to heavy rotting or cracking very quick. So I think, traffic will be an issue.
Two questions. In Taiwan, is there a typical type of aggregate, or do you have a wide range of aggregates at your disposal, carbonates and harder aggregates, or is it predominantly soft aggregates?
I'll answer this question first then. You're right, though, as the quality of aggregate play an important role in the pavement life. And what we have in Taiwan, for my study here, we have to check the quality of aggregate, which primarily the abrasion value should be lower than 30 or 40. So that's the checkpoint we use. Pretty much we have in Taiwan is limestone. I went to visit the asphalt plant here the other day, and then I saw a variety of aggregate used in Minnesota. That's opened my eyes. It's amazing. Why is there so many of them? Probably here's rich resources. But again, I think it comes down to the aggregate properties. that they use, and then whether they meet the requirement. I would say the shape, the angularity, and the abrasion values are three important issues. I will look into it.
Thank you. Second question was on laboratory performance testing, such as fatigue testing or complex modulus to utilize or try to predict performance, or at least part of the mixed design procedure to look at relative performance between different rejuvenators or wrap contents. Are you doing any work in that area, or is there any? It's something that's kind of just taking off in this country, and I'm just curious what your experiences have been.
Yeah, I haven't done that yet, though. I mean, you are right. We should have this test done to check the fatigue property, all the mechanics property for the wrap mixed with the rejuvenator, but we haven't done it yet. So thank you for the question.
Any more questions? Well, I can ask you one last question then. You said from academia to industry. So what can the academia do to improve, the quality of our pavements, in this particular case, asphalt pavements, with high amounts of wrap? Do you have any, that's what you said in the title, and what can we do here at the university, working with our graduate students, with our colleagues from industry, and from the Department of Transportation? So,
okay, I would like to mention a little bit the background of this project. Well, at that time when this project started, actually, I went to the Taiwan Highway Bureau to talk about this project with them. I mentioned that I point out that we have been used wrap for such a long time, actually high wrap contents, and with the rejuvenating materials. And people at the highway agency, they seem to me, they listened to my sort of proposal, and they started with this project. So this is my first time to be in contact with the paving industry, because I am in charge of this project. So I went to the Asphalt plant and tell them what you should do and what you should not do. And it's difficult. It's difficult to deal with them because they have, I shouldn't say it's difficult, but they have their ways of doing things. I have to get around with it. I feel that we people as academia, which reach out the industry to tell them what we can help them. And then they might listen to you. I just say might, because they have fixed mind in their head. They don't. But it takes time to communicate with them. And I think participating, like Professor Sudino, you're doing now with the Minnesota Pavement Association, I think that's a great start to talk to them. And what problem you have, what we can help, and then so we can have a sort of a middle ground in the middle to help each other out. I think with all the excellent faculty, well-known faculty here, I think that's what we should do, actually. That's what I'm working on right now, and then we'll put effort into it.
Any other questions? If not, let's thank Professor Jian-Shiuh.
Thank you very much. Thank you. Thank you.